This is GCSE Physics Past Paper Questions 5, and it's on Unit 5, and Unit 5 is on forces. So Unit 5 forces, June 06 to June 09. So the first question is from June 08, paper 2, and it says, the moment of a force is sometimes called the turning effect of a force. How is the moment of a force calculated? Now you have to write out the full word equation. So the word equation is that moment and it's equal to force multiplied by, and it's perpendicular distance from the pivot. So we're just going to write in here, I'm just going to write PER, distance from the pivot. Okay, so there's 2 marks for that, which I just wrote over. There's 2 marks. If you only wrote moment is force by distance, I'm going to write it over here. You would only be awarded 1 mark. So you need to write out the full thing to make sure you get your 2 marks. The other thing is that very often people will just write they'll just write force by distance. That's not an equation, and it's not how you would actually calculate it. You have to have an equal sign in anything that you're going to calculate. So you need moment equals force times distance. They will let you away without the perpendicular bit. Okay, part 2, state the principle of moments. So the principle is this idea of the moments being balanced. Now, to get 2 marks, you have to say something about when moments are balanced, or when an object is balanced, or a good word to use is at equilibrium. And equilibrium means balanced. And then you can say the clockwise moments I shouldn't have put an equal sign in there, just a wee comma. Clockwise moments equals the anti-clockwise moments. So that's 1 mark for saying at equilibrium, or when an object is balanced, and a 2nd mark for saying clockwise moments equals anti-clockwise moments. You will get away with the 2nd mark. You wrote CM is equal to ACM. That is a recognised way of shortening that, so you would get a 2nd mark for that instead. Alright, the next part. Philip balanced a plank of wood as shown in the diagram below. And that's that first bit. So he balanced a plank of wood. He then placed a box on the left hand side of the plank, which is here, and a suitcase on the right hand side of the plank. The suitcase was then moved along the plank until the plank was again balanced. This is shown in the diagram below. So we're assuming that the plank up here was balanced at its centre of gravity. And that means that there is no moment due to the weight of the plank acting through this pivot, because the centre of gravity acts through the pivot. So we don't need to worry about that when we do our calculation. So the question says, what is the moment of the weight of the box about point P? Okay, now if this whole thing is balanced, then what you need to do is calculate the moment of the box about point P. So it's the moment of this box about point P. So you're going to write down your equation, moment equals force times distance. Let me just move that up so you can see that. So moment is force times distance. So the force of the box is 150 newtons, and its distance is from the pivot. Now, there's space down here for a unit, so you can get away without changing your 20 centimetres into metres. I'm just leaving it as 20, provided you put in a unit which is consistent with that. So when you multiply 150 times 20, you get 3,000. I'm just going to write the 3,000 down here again. And the units are newtons multiplied by 20 centimetres, so it's newton centimetres. And so you got 1 mark for your unit, 1 mark for your answer, and 1 mark for multiplying 150 by 20. So the next part of the question then asks you, the plank is balanced when the suitcase is 18 centimetres from point P. Calculate the weight of the suitcase. Now if we look back at the diagram again, we already know the moment in this side is now 3,000 Newton centimetres. I'm just going to write that down, 3,000 Newton centimetres. So if that's balanced, then you must have 3,000 Newton centimetres on this side. And so we're going to say that the moment is 3,000 Newton centimetres and it's equal to this weight or force, of course weight is a force, times its distance from the pivot. So moment is force by distance. The moment is 3,000. The force we're looking for, and it's our weight, and it's multiplied by the distance, which is 18 centimetres. So to find W, you have to divide 3,000 by 18. And the answer is 166.66, so we're just going to round it up to 166.7. Okay, so you would get a mark for your equation, a mark for your numbers in there, a mark for your division sum, and a mark for your final answer. Now you will get away with 4 marks for your final answer with no working out, but you take a big risk. If you don't show any working out, you take a big risk that you get this wrong and you get nothing. But you might get this wrong and get everything else right. You've just made a miscalculation on the calculator and you could end up with 3 marks out of 4.